This is a video about prime decomposition. So we at this point have already looked at what a prime number is, and just to remind yourself, a prime number is a number which only has two factors. In other words, it can only be divided by two numbers, and those two numbers is the number itself and the number 1. Okay. Whereas a number can only be prime or composite. So a composite number is a number that can be made up of a product of primes. Okay, and that's why it's very important to understand what a prime number is first before looking at prime decomposition. The word composite in maths always means kind of multiple. Like when you think of composite shapes, it's when two or more shapes are put together. So a composite number is a number that's made up of a product of prime numbers. So the number 17, that's just a prime number. Okay, so I just wanted to demonstrate again what a prime number was. So 17 can only be made up of 1 and 17. Okay, so that's why that is called a prime number, because it only has two factors, the number itself and the number 1. Whereas the number 18, we look at that and straight away we can think of a few different factors. So when you are doing prime decomposition, you need to start with two factors. So some of you might right now be thinking, oh, well, 2 times 9 is 18, or 6 times 3 is 18. And it doesn't matter what you use first. So let's say, for example, 2 times 9 was what I thought of first. So we'll do 2 times 9. If you put 6 times 3, that is also okay. So now we get to this stage. Okay, what we've got to recognise, can either of these numbers be taken any further, or are they prime numbers? And hopefully you've spotted one of them already is a prime number, and that would be 2. Okay, the number 2 is a prime number because you can only divide it by the number 2 and 1. 9, on the other hand, is not a prime number. When we think of the number 9, hopefully we've thought of two factors, not 9 and 1, but 3 and 3. 3 times 3 will give me 9. And hopefully you also spot that we've come to the end of the road at that point, because 3 is also a prime number. And of course, if that 3 is a prime number, then so is the other one. Oh, didn't want to clone this 3. Okay, so once you've reached kind of the end of the road as I've described it there, you'll notice that each end we've been left with prime numbers, and that is what you call prime decomposition. In other words, the number 18 is the product of 2, 3 and 3. Remember, the word product means to multiply factors. Okay, so the prime decomposition of 18 is 2, 3 and 3. Let's look at another one. Let's look at the number 60. Okay, again, you can start with any two factors of 60. It is totally up to you. The first two numbers that come into my head is 2 and 30, but you can start with any two factors. What you'll notice is that actually we've found a prime number straight away, the number 2. So sometimes these are referred to as trees. That tree can't go any further on that branch. The number 30, however, can be split up even further. So So again, when I think of the number 30, I think of 2 and 15. Okay, so like I said, you're just looking for two factors, and I've picked 2 and 15. What I've found again is another prime number. So the tree's ended at that point. But of course, 15 has different factors. Okay, so 15, well, that can be made up of 3 and 5. And hopefully you've spotted at that point we're done, because 3 and 5 are both prime numbers. So my factor tree or prime number tree, it's referred to as lots of things to be fair. You know you're finished when you've basically got prime numbers all the way at each of the ends. Okay, and to finalise or finish your answer, so we started with the number 60, which is a composite number. Composite number means it is a product of prime numbers, which are 2, 2, 3, and 5. That would be your final answer.